So next we'll be doing the definition of construction stage in the software. So in the first stage, CS0, the duration will be 1 day and we'll be activating peer and peer cap elements with the age of 28 days. In the next stage, CS1, we'll be activating the first span. The age of the first span when launched will be 21 days. Then the next stage, we'll be activating the second span, and subsequently in the next stage we'll be activating the third span. Then finally we'll be applying the crash barrier and bearing coast load, and we'll consider duration of the last stage as 10,000 days for long-term creep and shrinkage calculation. So we'll go to loads and construction stage and define construction stage. One can go from here also. This is the shortcut. You click on add. We'll give the name CS0. Duration will give 1 day. In the element tab, click on CS0. Give the age 28 days for peer and peer cap elements and click on add. Then boundary will be activating the substructure boundary with peer and peer cap elements. So I'm adding the boundary in the activation window. And then switching to loads, we will just be activating self rate. So I'm bringing self rate into activation window, and then we click on OK. So the first construction stage CS0 is defined, and then we'll click on add. Name will give CS1, construction stage 1 definition will do. Duration I'll give 7 days. Element I'll activate CS1, construction stage 1, superstructure elements with 21 days strength. I'll add it. And then boundary, I'll be activating construction stage 1 boundary wherein the rigid links of superstructure are grouped. Then I'll be activating loads. So again, first I'll be activating PS11, which is the first set of stressing. Then if you see over here, I can activate the loads either at the starting of the stage or at the end of stage. So I need further steps so that I can add the stressings, further stressings after 1 hour. So I go to day. Over here I will put 0.02, 0.04 and 0.06 and click on add. So these are additional steps in between the 7 days duration. I can add a number of steps. So these correspond to 1 hour duration after the starting of the stage. So I will select PS12, which is the second set of stressing. I will activate it at 0.02 time interval. Add it. Again, PS13 I'll be activating after an hour. So active day will be 0.04, and PS14 will be activating at active day 0.06 and add it. When we click on OK, so this definition of construction stage 1 is complete. Then I'll click on add. Now same way we'll be defining construction stage 2. Duration will be 7 days. Construction stage 2 element I'll be activating with 21 days strength. We'll click on add. Boundaries, again I will activate construction stage 2 boundaries. And loads I'll be activating first PS21. I'll be again putting here additional steps 0.02, 0.04 and 0.06, and I'll be adding the additional steps. Then I'll activate PS22, which is second set of stressing at day 0.02, then PS23 at 0.04 and PS24 at 0.06 day. And I click on OK, so this also gets added. Exactly the same way we'll be adding construction stage 3. Duration I'll give 7 days. Element I'll be activating construction stage 3 element with 21 days strength. And boundary I'll be activating construction stage 3 links. So CS3 boundary group. And then load wise again the same way, PS31 I'll be activating at the starting of the stage, and 1 hour gap steps we will add over here 0.02, 0.04 and 0.06. Click on add, and then I'll be selecting 0.02 day, and then I'll be adding PS32, PS33 at 0.04 day, and PS34 at 0.06 day. Add it, and I click on OK. So this completes the definition of construction stage 3. Then the last stage definition, I will give the name CS4. Duration I will give 10,000 days. So everything is activated in elements, boundaries. I'll switch over to loads and I'll be activating superimposed dead load at the starting of this stage so that it will be considered for the long-term effects. I click on OK. So this completes the construction stage definition. I'll close this. Then I'll go to analysis and construction stage analysis control. So here actually I need to segregate the dead load output of construction stage. So I need to click on add and I'll select SIDL weighing course. I'll bring it to right side and I'll give a name SIDL weighing course and click on OK. Again, I'll be separating out SIDL crash barrier from the output of construction stages. So I will just give a name SIDL crash barrier, add it. Again, basically for Indian code, we consider the beam section properties to be constant. So this option should be switched to constant. And then we can click on OK. After that, we will be defining the moving load analysis control. So click on the moving load analysis control. Over here, we will check these options, normal plus concurrent forces and combined stress calculation. And then we can click on OK. And then we will break down the tapering sections into individual sections. So we go to properties and tapered group. We will be selecting all the tapered groups and we will click on convert to tapered section, click on OK. So now you can scroll down, click on close. So now you will find individual sections will be generated for support to mid properties. So next we'll be defining the reinforcement in the cross sections for the design purpose. So we'll go to section manager and reinforcements. So I'll define for the mid section reinforcements. I'll click on this multi-add, select the reference centroid, and then the reference will be centered top of the box cutter, and then Z value I will give as 0.06, which is the effective cover for reinforcement. A number of rebars I'll give 35, spacing of rebars I'll give as 0.25 meters, and diameter of rebar I'll be selecting P20, 20 mm. I'll just copy this and paste it again. So I'll just change this input for reference Z to bottom, and then in Z direction the cover, effective cover remains same. Number of rebars I'll change it to 19, and the diameter of rebar I'll change it to 16. I'll again come down to the next cell and click on OK. So you can see over here the reinforcement is defined at top and bottom. So this reinforcement will be considered for the capacity calculation of section. Again, for shear reinforcement definition, I can go to shear reinforcement. So for shear reinforcement, I need to check this diagonal reinforcement option. Pitch will be the spacing of shear reinforcement. I'm giving 150 mm. Angle I'm giving as 90 degrees. That will be parallel to the web, and AW corresponds to the area of shear reinforcement. So I'll be putting over here 20 mm diameter, 4 legs. I'll click on OK. And for torsional reinforcement, I'll check this option, torsional reinforcement. Pitch I'll keep same as the shear reinforcement. AWT actually is the diameter of the enclosing rebar, so it is going to be same as the diameter of shear rebar, which is going to be E20. Number will be just 1, and OK. And then we need to enter all the enclosed longitudinal rebars by the torsional loop. So ALT value I'll roughly put around 16 dia 40 bars, and click on OK. Then I'll click on apply. So this completes the definition of reinforcement for midsection. I can copy this reinforcement to the support section. I'll bring it to right side and click on OK. So the same reinforcement will be copied to the support section as well. So you can see these are the rebars and support section. Then I can close this. Then we can click on perform analysis button over here, or you can press F5 for performing the analysis.